Here are your solutions to the last one. I am proud of you that you did the first three, and that now we just have one more left. Let's do it together. Obviously, you should try it first. If you're a little tired, you just want to listen and try to figure it out with me, it is what it is. The graph of a piecewise is here from -1 to 4. What is the value of the integration from -1 to 4? That means area, right? So this area is a trapezoid. That's 1/2. You add the bases, so 3 plus 1. And then the height of the trapezoid is 2. And then we have another trapezoid that's negative. That's down there, so really I should go negative. And it's 1/2. The bases are 2 and 1, so that adds up. And the height of it is 1. And then if I put it together, I got 8 minus 3 over 2, or 8 minus 1.5. So what is that? 6.5? That's what I get. No! What happened? Let's try it again. So half the bases times the height, I like that one, minus the bases are 2 and 1, and the height is 1. Oh, well, half of 8 is not 8. Silly. It's 4. And then 4 take away 1.5 is 2.5. Well, that answer is there. All right, don't give up, right? It's all good. F is continuous from A to B and differentiable. Which of the following could be false? So if it is continuous and differentiable, I rock equals A rock for something, yes. Sorry, that's true. We're looking for false. The derivative of that equals 0 for something there. So we don't know that. There's a maximum value from A to B, so could be false. There's a minimum value, or the integration exists. So if it's continuous and differentiable, this one exists. Now look at B, D, and so on. So C and D has a maximum value and has a minimum value. So if something is continuous, it's either going to look like this, or it could look like this, or it could look like this. But somewhere, if you have endpoints and something is drawn, there's going to be a maximum minimum value if it's continuous. If there's a hole at the ends, then no. But if it's continuous, yes. So there's some maximum value, there's some minimum value. The only thing we don't know is if there's a turning point. That's what this is. So this one may be false. The rest may be true. 6, you're given an equation. Can you do the second derivative, or the first derivative, and when x equals 2, what does it equal? So first of all, when x equals 2, let's plug that in and figure out what y equals. So 2 squared, 2y equals 10. So I'm going to solve this. So that's 4. So 10 take away 4 is 6, and then divide by 2. So now I know what y is, and I know what x is. So I need both 2 and 3. Now I'm going to take the derivative implicitly. So the derivative of x squared is 2x. X times y. The first times the derivative of the second, plus the second times the derivative of the first. And then the derivative of 10 is 0. Now, plug in. Well, first of all, now let's get y prime by itself. Let's be accurate. So to get y prime by itself, we are going to subtract these. So I'm going to subtract 2x and subtract y, and then divide by x. So I have negative 2x minus y over x. Now I plug in these numbers. So I have 2, and I have 3, and I have 2. So negative 4 over 3. That's negative 7 over 2. So the answer is A. Number 8. Let f and b differentiable functions. G is always positive, and f at 0 equals 1. H equals this. The derivative equals this. Then f at x equals what? So I'm going to take the derivative of h at x. That's the first times the derivative of the second, plus the second times the derivative of the first. I'm going to make it equal to f at x times g prime at x because they're equal to each other. So I have f at x, g prime at x. So I have them on both sides. So what I'm equal to is g at x times f prime at x. Oh, so if this is true, if h prime x equals, it's not that they cross out, that they must be equal then to 0. So f at x so if I solve this, and it says that f at 0 equals 1, so then this must be 0. So 0 times, right, 1, this must be 0. So that means it must equal 1. All right, moving on. What is the IROC of change at x equals 2? That's derivative. So to do the derivative, we're going to do the quotient rule. That's the bottom times the derivative of the top minus the top times the derivative of the bottom and the bottom squared. Then I'm going to plug in 2 everywhere. So 2 take away 1, and 2 times 2, that's 4. 2 take away 2 squared, take away 2, that's 0 times whatever. And then 2 take away 1, and then I get 4 is my answer. What? It's not there. So the bottom times the derivative of the top minus the top times the derivative and the bottom squared. Plug in 2 for x. Let's try it again. I still get 4. Oh, 2 squared take away 2 is 4 take away 2, which is 2. And now I get the answer 2. So that means the answer is D. It's all good. Turn the page. Number 12. Find the limit at 2. So if I plug in 2 here, I get ln 2. If I plug in 2 here, because it's got to be the same in both directions, I get 4 ln 2. So it doesn't exist. Because one gives me ln 2 and the other gives me 4 ln 2. They're not equal to each other, so the left has to equal the right, so therefore it doesn't exist. A particle moves along the x-axis. Its position is given by this time. For what value of t is the velocity of the particle? 0. So take the derivative, make it equal to 0, and solve it, and I get the answer 3. Sometimes they're simpler, right? Here's a function. Find the derivative of it. So the derivative of sine is cosine, copy. Then the hook, copy, e to the, and then one last hook, which is -1. So look carefully, which one matches that perfectly? So when I look, I see negative e to the negative x cosine. It is e is the one that matches it. Number 18. Find an equational line tangent to that graph at that point. That's derivative. So first of all, I know x and y. So we have x and y. I got it. The derivative of that is 1 minus sine x. Then when I plug in 0, no, sine at 0 is 0. So I'm just left with 1 for the slope. So the slope is 1, x minus 0 plus 1. So I got y equals x plus 1. So the answer is B. You can try these first. What are all values of k for which this is true? So I'm going to integrate this first. That means I'm going to add 1 to the exponent and divide from -3 to k. And then I'm going to plug in k first, subtract, and then I'm going to plug in negative 3, and I'm going to make it equal to 0. So I integrated, I plug in k, then negative 3, make it equal to 0. You can multiply everything times 3. This is negative 27, and a negative makes it plus 27. You can cube root a negative number. So negative 3 times negative 3 times negative 3. I get negative 3 as an answer. So that's A. Done. 22. The function f is given here, and which of the following is f increasing? That's a derivative question asking for increasing. So read the question, know the calculus, and then do the calculus. So it's derivative. I can do that calculus. 4x cubed plus 2x. And then make it equal to 0, and we're going to draw a number line soon. So we're going to factor out a 2x. That's x squared plus 2. This will never be 0, so the only answer is 0 is the only number that would make all of this 0. And then plug in. So if I plug in a negative number, it's a negative times a positive, and then a positive times a positive. So where is it increasing? When it's 0 to infinity. Number 22. 24. The maximum acceleration attained by this particle whose velocity is that. So let's first of all, let's find the acceleration, which is 3t squared minus 6t plus 12 equal to 0. I'm going to divide out a 3. Oh, you know what? If I want to find the maximum acceleration, once I have the acceleration, to find the maximum value of the acceleration, I take the derivative of the acceleration. That gives me 6t minus 6 equal to 0. I get 1. So from 0 to 3, if I plug in a half, or if I plug in 2, so it's going down and then up. So whatever the value is, it's going to go down, and then it's going to increase, 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 and then at 3 will be the highest in terms of the acceleration. But a minimum's at 1. So I say at 3. Oh, and then you actually have to find it. So then you have to plug 3 in. Sure, I'm doing it right. So you could also plug in 0, but 0 gives you 12. If I plug in 3, that's 3 squared minus 6 times 3 plus 12. That's 27. Take away 18. 9 plus 12. I get 21. There's my answer. Sticking to it. (26) The function f is continuous from 0 to 2 and has values that are given in the table. The equation f at x equals a half must have at least 2 solutions on the interval if k equals what? So if I graph this 0, 1 and 2, 2, for there to be a solution here, this is where half is, you would need something below. So at k here must be below a half. So the only answer that's below a half I see is 0. Because all of it has to be, so it has to be able to go down and then up so that it has 2 solutions. 28. Take the derivative. I know you can do that. So the derivative of tangent is secant squared, and then there's a hook, and then you would plug in pi over 6. Now 2 times pi over 6, the 2 goes into 6, the 2 goes into the 6 3 times. Now you got to know your unit circle. So cosine at pi over 3 is the x coordinate there, which is 1/2. Secant at pi over 3 is the reciprocal of that, which is 2. So it's really 2 squared times 2, which is 8. I know. The graph of a function f is shown above. Which of the following statements is false? It's continuous at x equals a. That is false. I don't even want to go any further than that. There's a hole at a. It's not continuous. Done. Okay. The radius of a circle is decreasing at a constant rate. In terms of circumference, what is the rate of change of the area of the circle in centimeters per squared for number 78? So the radius is decreasing at a rate of negative, it's negative because it's decreasing, at 0.1. The area of a circle is pi r squared. The derivative, so it says the rate of change of the area. There's area. Take the derivative with respect to time. Needs that hook. And then we need to plug in. And then remember that circumference is 2 pi r. So 2 pi r is the circumference. dr by dt is negative 0.1, and that gives you what you're looking for. So which one has that answer? B. 80. The first derivative is given. How many critical values does f have on the open interval? Well, it can't be 0 because that's undefined. And then if you make it equal to 0, this is a graphing question. We need a calculator. I was like looking at the answer key, like, all right, let's look at the answer key. So let's graph this. So I'm going to graph exactly what I say. I'm going to graph the derivative. So I'm going to graph cosine squared. Now it's a little tricky, right? Cosine squared. Go parentheses, go cosine, and then square it. So it looks like that. Can you practice with me? Cosine, that's going to be cosine squared over x. And then, what are we doing? Subtract 1/5. Now, we got to change the window. So it goes from where? 0 to 10. So menu, window, and then from 0 to 10, and then just cross how many times it crosses. So it crosses, let's see, 1, 2, 3. I just see 3 from 0 to 10. So 0 doesn't count because it's an open interval. So 0 is not going to count. Boo. Right? It's not a thing. So between 0 and 10, how many times does it cross over? And the answer is 3. All right, these we can use our calculator if we need to. All right, last group, with our calculator. Try it. This one doesn't need a calculator. 84 does. The derivative and the function are the same. So that means it's e to the x, I think. Is that what it's telling me? Oh, whatever. Okay, so then, all right, 1 second. I'm going to come back to this.